This is section 10.2, and today we're going to talk a little bit about arcs on circles. And so when you're measuring kind of around the outside of the circle, not anything through it, but anything on the outside, that is called an arc. And we'll start by talking about a central angle of the circle is just an angle, make sure I say that right, with its vertex at the center. An example of that for us would be like angle ACB. That would be called a central angle. It has its vertex at the center. The measure of a central angle is actually equal to its arc. And that is the theorem that we're going to put on our card down here, is that idea right there, is that the measure of a central angle is equal to its arc. So if this angle was 50, then its arc was 50, and vice versa. If we knew the arc measure, then the angle measure is the same. So we have minor arcs, and they is an arc, okay, less than 180 degrees. So in our case, a minor arc on this picture would be AB. And when we do an arc, now we want to change our notation to be curved. You're talking about the outside of the circle. That is different than doing AB with a segment on top of it. These ones kind of look like they might be straight, but they are arced. So different than segments, these are arcs. You're talking about doing the curved side of the circle. So we're not going into the circle, we're just covering the outside where the arcs are. A major arc is an arc that is greater than, 180. So for us, a major arc could be A, D, and then B. And the reason major arcs have 3 letters is because if we just said A, B again, we wouldn't know if we were talking about going the short way for a minor arc or if we were talking about going the long way for a major arc. So anytime you see 2 letters naming an arc, you always have to go the shortest distance possible. If you see 3 letters, then you have to follow the arc so that you hit the letters in that order. So we'd have to hit from A, then D, then B, and that would definitely be a major arc. That's much bigger than 180. Then we have semicircles is an arc that is 180. And we don't really have one in this picture, so I'm just going to add it. I'm going to extend that, make that a diameter right there, and we'll just do point E. And then our semicircle could just be BE. We could use that either way because either direction is the same amount. You could also say BAE, or you could do BDE. Either one of those would work. So those are our different types of arc measures that we're going to be using, and then just knowing that the one rule is that the measure of the angle is equal to its arc. We kind of talked about it, but be careful naming arcs. Use 3 letters when naming a major because you need to tell everybody that you need to go around the circle in the bigger path. So on your theorem card, you just have one box for 10.2, and it's just to summarize that. It's just to say that the measure of a central angle is equal to the arc. So the little like shortcut or the tip down at the bottom would be is that like arc ST is 80 degrees. So the arcs are equal to the central angles. And that's also equal to, we have to stick a letter here. Let's call this circle A. That would be equal to angle TAS. Okay, so arcs are equal to your angles, central angles. We'll just do a few different examples of this. So the first one says, find the measure of each arc of circle P, and RT is a diameter. Just so you can tell, that's a T, a P, and an R. And they're telling you that this is a diameter, which means it's 180. So if that much is 110, I can figure out this, which is 70. And then this side would be 180. So let's come over here. I know you have the notation here. RS, so we're just going the shortest distance possible. RS is right here, and if that's 110, then we are 110. RTS tells you that you have to travel from R to T and then to S, so you're doing 180 right here, plus that 70 gives you a total of 250. Make sure you're putting degree symbols on these. These are arc measures, and we use a degree to measure that. Next one is R to S to T, so make sure you're traveling R, then hit S, then hit T. And that's a semicircle, so that is 180 degrees. Another picture here. These letters are not copying very well. That's an E, that's the B, D. These all have arcs on them. So you're just finding the measure of each one of these arcs. First one is from A to C, so here's A going to C, and I just add up the central angles that are associated with those arcs. So 29 plus 108 gives me 137. Next up is the measure of ACD, so to go from A to C, then to D. So I'm adding 83, 108, and 29, and I get 220. Next up is ADC, so traveling the other way, A to D to C. So I've got an 83, a 61, and a 79 gives me 223. Last one is E to B to D, so E to B to D. All of those get added up, or the alternative you can do is the whole circle is going to be 360. We could just subtract 61 because that's the only one I'm not using, and I would get a total of 299. One more example for you before we go for the day. So identify each as major, minor, or semi, and determine how much the arc is. These all have arcs on them. Sorry about that. I know your notes have them. So let's look at the picture real quick. We've got 120 there, a 60 there, an 80 there. The whole circle adds up to 360. So we're just trying to figure out how much is left for this, this one central angle right here. So I'm going to take 360, and I'm going to subtract the 80, the 120, and the 60. So it leaves me 100 for this angle. So now if I want to find the measure of TQ, that is a T. So from T to Q, shortest distance possible, that would be 120, and that is a minor arc. Next up is QRT, from Q to R to T. So I could do 360, just minus this 120. That gives me 240. That is a major arc. Next up is T to Q to R. So T, that's 120, and then Q to R is 60 for a total of 180, and that is a semicircle. Next up, I've got Q to T to S. So I have to go Q, 120, then to S with an 80. So that is a total of 200, and that is a major. Next up is T to S. That's just an 80, and that is a minor. Next up, I've got R to S to T. That is also 180, another semicircle. So big idea is that the angle is equal to the arc, and vice versa. If you know the arc measure, that is also equal to the central angle.